In this lesson, we will transform exponential functions. So really, it's the same thing we did before when we did the transformations unit. The one thing you have to remember about transforming exponential functions is that there are actually an infinite number of exponential functions you can transform because it really depends on what the base is. So your base function or a parent function, that can change depending on what the base is. So for example, if you look at example 1, the base is 2. So you have, let's say, a set of points that you're going to transform using the mapping rule. And then for the second example, it's half to the power of x. So you have an entirely new set of points that you're going to work with. So as every time you change a base, you'll have to work with a new set of points. But luckily, it's actually not that bad because you always have a guideline to work with. So I'll show you what I mean by that. Okay, so let's do the first example. You can make the argument that you don't really need to use the mapping rule and the original function, original points, but we're just going to keep it consistent. Even though we're just applying one transformation, we're just applying a vertical translation 3 units up. We're still going to, use our technique from the transformations unit. So the mapping rule here is xy becomes x and then y plus 3 because we're applying a vertical translation 3 units up. So what are the original points? All right, so the original points, now even though they can change every single time you transform an exponential function, the x values are always the same, -2 to +2. Why is that the case? Because if you think about an exponential function, you really just want to work with 2 points to the left and 2 points to the right of the y-axis. And of course, you have the point on the y-axis, which will give you a very, very nice transform function. Okay? Because if you think about it, the center of the graph occurs right here, where it begins to increase or where it begins to decrease. All right, so this is a quarter, a half, 1, 2, and 4. So g of x, so these are the points I'm going to plot. So if you add by 3, it'll be 3 1/4, 3 1/2, 4, 5, and 7. So students always ask me, can I change it to decimal? And my response is as long as it's exact. So in this case, it's exact. So you know what? Go ahead, change it to a decimal if you want. Okay. So after I graph it, I'll say something about the horizontal asymptote and its relationship between the transformations. Okay, there's my scaling. 1, 2, 3. All right, what is it? 4, 5, 7. Beautiful. So one thing you should note is that the location of the horizontal asymptote will help tremendously when it comes to graphing an exponential function. And the location of the exponential function, the location of the horizontal asymptote will depend on the vertical translation, solely on the vertical translation. So if you know the vertical translation, you know exactly where the equation of the horizontal asymptote is. And if you think about it in terms of transformations, that makes perfect sense. A vertical stretch won't impact the location. A reflection across the x-axis won't do it. A horizontal compression won't do it. A horizontal translation won't do it. The only transformation that will determine where your horizontal asymptote is your vertical translation. All right, so we're basically going to do this quite a few times. We're going to do the mapping rule, get the original points and then transform them and sketch in the horizontal asymptote, and then you're pretty much done. So this is adding by 3 here, negative 2y minus 4. So these are my original points. Now be careful, the base is half, but don't worry. The x values are still ranging from negative 2 to 2. That gives you the center of your graph. So when you plot the points, look at the first example, you'll get something very beautiful. You can connect the dots and get a very nice curve. Okay, so let's do the x values first. You're adding by 3. And then the y values, you're multiplying by negative 2 and then subtract by 4. Okay, so I'm looking at those y values. I think I have to change up the scale. And go by 2s, let's say. Now before I sketch in, well, let's do a scale first. And then I really want my horizontal asymptote, which is at y equals negative 4. Because there's a vertical translation 4 units down. Okay, there we go. I really hope you appreciate the usefulness of a horizontal asymptote when it comes to graphing the transform function. It gives you a guideline of how the graph is look. All right, and I'm hoping you can see the similarities between what we're doing in this lesson and what we did before when we graphed all those functions, when we did the transformations unit. Let's factor out k. Oops, 1/9. So I already know that the horizontal asymptote is located at y equals 1 because there's a vertical translation 1 unit up. I know it's a little confusing because the vertical translation is controlling where the horizontal asymptote is. Anyways, yeah, that's very useful though. All right, so let's find the x values first. Negative, so it'd be 1. Okay, and now let's sub in the x values here. So negative 1/18 plus 1. Okay, all right. So for the x-axis scale, I'm going by halves. And for the y-axis, I'm gonna go with, oh, those are not pretty to work with, but I'll go with 1. Okay, so I'm gonna plot this first, -2. Actually, whoops, let's do the horizontal asymptote. Oops, there's your y equals 1 because it's a vertical translation 1 unit up. And then let's plot -2, -3.5, -1.5. Oops. -2, 3.5. I forgot my scaling. -1.5, -0.5. And then -1. Alright. Those last few points are pretty hard to graph, but yeah, just try your best. 17/18. Ooh, that was hard. Okay, let's try last one. Alright, graph f of x equals negative. Let's factor out the -1 here. Okay, so I'm going to assume let g of x be 2 to the x. So if that's the case, my mapping rule is like that, because I reflect across the y-axis and the x-axis. I went 1 left and 4 down. Alright, sketching the asymptote. There we go. So basically exactly the same thing we did with the transformations. You identify the base function or the parent function, identify the mapping rule, grab your original points, which are pretty easy because the x values always range from -2 to 2, and then use a mapping rule to find the location of your new points, sketch in the asymptote, the horizontal asymptote, and then plot the points and you're done.